Hi, my name is Brody Park. I am a junior at Walton High School, and I've been coding and learning artificial intelligence since the sixth grade. And this is my fifth year competing in the Cobb County Technology Competition, which I have won first place the past 2 years. And last year, I also won the state competition first place. My project that I will be presenting today is a cumulative representation of everything that I've learned and my progress since my first competition back in sixth grade. And I've been working on this project for about 5 months now. So let's get started. So, why do stock prediction? Well, it's a real world problem, and there are many complexities to it, and especially the market data. And it is the perfect problem to use AI to analyze it. So, what I've done is I use everything that I've learned about machine learning algorithms, particularly neural networks. And to solve this problem, I used several libraries. Libraries I've used are PyTorch, which is the machine learning library, or you use Pandas and NumPy, which helps with data analysis and handling. And I've used Matplotlib, which helped me graph all the data, which you will see later. Okay, so before I get into the code, I want to explain what data I'm using and which model I'm using. So the data that I'm using is Google's stock prices from the year 2004 to 2023. And this is about 5,000 days worth of data. And this data set includes the date, the open price, the high price, the low, and the close, the adjusted close, and the volume for each day. And I will show you the data set. So this is the data set. As you can see, for each day, you have the date, there's a high price, close price, etc. So I will get to the pre-processing later in the code. So the model that I'm using is an LSTM model. It stands for Long Short-Term Memory Model, and it is very proficient at taking in chronological data, unlike other AI models like an RNN. And the LSTM has a memory, which helps it retain important information, and it forgets unimportant information. It has a cell state, which is you can see in the C or the CT minus one. That's what that represents the cell state, which is the long memory, and then you have the hidden state, which is the short-term memory. Okay, let's get into the code. So to pre-process all of this data, I turn the data set into a pandas data frame. See, I do that here. And then what I want to do is I drop the date and the adjusted close because when I'm inputting data into the model, I am only allowed to input float types. And the date is a string because it has dashes in it. And float types are only numbers and decimal point numbers. So then I create a list of all the truth values. And the truth values are the close price of the next day. So my model, it takes in information every single day. So it takes in information from the first day. And what it's trying to do is trying to predict the correct price, the closing price of the day after it. So I create a truth value list, and I offset that by 1 because when I take the normal truth value data, and I put that into a list, all of that will be same as the same day close value, which I want it to be the next day's close value. So then I use something called standard scaler. As you can see, the volume column for every single day at the end of it is an abnormally large number compared to the rest of the data inputted. So the problem with that is it will influence the weights and the gradients of the model, and way too much, way more than the other types of data. So fix that. What I do is I use standard scaler. And what standard scaler does is it changes the values of the numbers. So the mean or the average turns into 0, and the standard deviation of 1. So that means the lowest value out of all of these volume for each day will be -1. And the highest value will turn to 1. And everything in between that will be between -1 and 1. So this allows the model to not be influenced so much by the volume and will be influenced the same for every single input value. And then what I do after that is I turn that data set into that pandas data frame into a data loader, which is what's inputted into the model. So what I want to get into next are something called hyperparameters. Hyperparameters are adjustable settings that control how an AI model works. So for example, learning rate. The learning rate is the bigger the number, the faster the model learns. But a problem comes with this. You don't want the model learning too fast because sometimes it can overshoot what the optimal value is supposed to be. The next hyperparameter is hidden size. And hidden size is how many cells the model, how much information the model retains. Then you have the number of epochs. The number of epochs is the number of times the model goes through the entire data set. And the reason that is such a large number is I will get to that later. The number of layers is how many hidden layers there are at one time. So the more layers, the more complex the model is. And patience, I'll get to patience later. And the reason I have each of these values the way they are is because I did something called a grid search. And so it basically went through and tested a bunch of different learning rates, hidden sizes, number of layers, and all these numbers were the optimal numbers to create the most accurate model. And then I made a function. This predictions function, it graphs model output values versus truth values, which helps me see how the model's doing throughout every epoch. So now I will go through the training loop. So it loops through the data set. So every epoch is one time the model goes through the data set. So every time it goes through the data set, I have another loop that goes through every single day. And every day is inputted into the model. And down here, as you see, line 21, this is where I get the output value. So I set the output values equal to the model. The model returns output values, what it thinks is the correct close price of the next day. Then I compute loss. What loss is it's a calculation of how far the model predictions were from the truth value. Then I get into the optimizer. What the optimizer does is it adjusts the weights, the gradients. It changes, and how these weights work is there's a set of weights for every single input value. And the larger the weights are, the more the input value will affect the model. So the model determines whether it should up the weights or lower the weights. So if it lowers the weights, that means it wants the specific input value, say the open price of the day, to affect the model's output values less. Okay. And then here is where I get into patience. So what patience is it's a number. And if the model is going through every epoch and it's loss, which the lower the loss, the better the model's predictions were. And if the model has gone, so my patience is 10. And so if the model goes through the data set 10 times without the loss getting lower, or aka the model is not getting any better within 10 runs, then the loop stops. That is why the number of epochs I had up here in the hyperparameters is so high, because these values will never be reached. So then the model, most times the model, the max number of epochs, the max number of times the model went to the data set was between 40 and 50 times before it reached a plateau. Okay, so then now I created a function, and this function creates the model, creates the LSTM model, and it gives the model all of the hyperparameters. So remember, the hyperparameters had learning rate, the number of epochs, the number of layers, the patience. So this is where I input all of hyperparameters into the model. And then another part of the grid search was I determined which type of loss function was the best. So what I came to, the conclusion was MSE, mean squared error. It's a type of loss function. That was the best one. Then the optimizer, there's also different types of optimizers. So Atom was the best optimizer over SGD. And then here I will get into some of the graphs. So the first epoch, the first time I went through the data set, the top left is what it looks like. So the blue line is what the model predicted, and the truth value is the orange line. And so as you can see, the on the complete left side at 0 is the first time the model was ever even given a day. It predicted some crazy number at 120. So it didn't even know what the range is supposed to be um, predicting was. So then it quickly learns that what the range is, and you can see the blue line is pretty rough, a rough estimate throughout the entire data set. But at epoch and the average difference, that is the difference between for every day what the model predicted, the difference between what the model predicted and what the actual value was. The average difference was $2.1. And then that number at epoch 10, the 10th time it ran through the data set, the model, the average difference between what the model predicted and what the truth value was $0.9. At epoch 20, the average difference was $0.8. And at epoch 30, it was $0.77. So it's continually getting better as there are more epochs. So that means it has not plateaued yet. And then at epoch 40, the model reached an average difference of 0.73. And after this, the model plateaued, which is why you don't see any more graphs, because there were no more epochs. So here is where on the right side of the screen is the total loss graph. So remember, loss is how far the model was from the correct answer. So as you can see, as the first few epochs, the first few times I ran through the data set, the loss value was super high, which means it was inaccurate. And it quickly, up until about loss 10, it quickly dropped. And 10 through 20, it was continually getting better up until 30. And then 30 through 40 is where it plateaued and was not getting better. So some of the challenges that I faced during when I was making this was the data processing. So since it was such a large data set and there were so many different values that I had to change and tune, that was one of the biggest struggles I had. And tuning the neural network was probably the hardest thing that I had to do, that I had to overcome. Since they are so complex, it took me a while to find the correct optimal architecture and the training parameters. So what I learned during making this project was I gained a much better understanding of machine learning techniques and which models to choose, like an RNN versus an LSTM. And an LSTM is better with chronological data, etc. And I also learned how to pre-process data, which is very important when inputting data into a model, because you don't want to give it stuff it doesn't need or stuff that will affect the outcome negatively. And this project also helped me learn about tools like PyTorch or Matplotlib. Okay, so in conclusion, I have successfully built an AI-powered stock prediction model that is functional, it is optimized, and it shows my strong understanding of all of these machine learning concepts. And it is not for commercial use. So some future improvements that I would like to make to this model was I plan to integrate more features like using several data sets, like over from different companies that are similar. and maybe adding alternative data other than just stock prices. And all of this can improve the accuracy of his prediction. So as you can see at the epoch 40, it reached a plateau and the average difference was 0.73. If I added more data sets or alternative data, I can probably get all of this, the average difference much lower and more accurate. Remember, this is a stock prediction model, so its users want to be as accurate as it can, so the losses are minimized. And additionally, I want to create a real-time version. So this could be used for day traders, and it can predict stock prices minute by minute instead of day by day. Thank you for listening to my presentation.